guys. So today we're going to be using the 4-1 to 4-3 information on all the shortcuts. Is that the door? No? Yes? Okay, I'll get it. So 4-1 through 4-3 to build up to the 4-4 material. In order to do that, we're going to kind of review some of the topics that we did, the things we did, the properties we did along the way. Go through and do that. Kennedy? That's it? Yeah, you didn't need to take this. Okay, so some of the things that we talked about along the way, guys, we have been doing a lot of them. This is one of the most common ones that we've been seeing. When you see two triangles that are like this and they share a side in the middle, how do I know this side is congruent to itself? What says something is congruent to itself? Oh, you got to know that property, guys. I'm not saying it. Look back in your other notes. Take them out, flip, do something. I'm not telling you what that's called. What is it called when something is congruent to itself? Okay, we'll go to the next one. Guys, I'm not giving them to you. This is like you have to actually remember this stuff. You have to carry things over. You can't just forget everything you learned in the first 9 weeks. The next one, when you have two triangles where they overlap and they share one in the middle, what kind of angles are these in the middle? Vertical. Vertical angles are what to each other? Vertical angles are congruent. That's one of the things you're going to see along the way. They can call that lots of different things. Definition of vertical angles are congruent, all those kind of things. From there, another one that you see a lot is going to be, what's the measurement on a right angle? 90 degrees. So if we have two right angles, what are we going to know? If they're both right angles, so you have a picture like this, and you have two right angles, what do you know about these two angles? They're what to each other? Congruent. They're both 90, they're going to be congruent because all right angles are congruent. Because all right angles are how many degrees, guys? They're 90. Because they're all 90 degrees, they're always going to be congruent to each other. Okay, let's think of another one. What if we have this, and it is right here, and it tells you this is a segment bisector, and this is this, and this is this. Remember we had that where a line cut through another line, and it cut it in half, so the two parts were equal? That's going to be segments bisectors. Segment bisectors are going to cut pieces in half. Not only do you have that when you have segments, you can also have that when you have angles. If you have a line in here and the angles are marked congruent to each other, you can have angle bisectors. There's so many we did, guys, along the way. There's the addition property of equality. And I'm saving that last one for the one we have to know because it's the most common one that's used on all of this. It's going back to this first one right here. Addition property of equality. I'll put that on there first. Or congruence. It could be congruence or equality. Okay. Got to go back to the first one, guys. I'm not moving on until you get that. So rip out the notes. Do what you need to do. What says something is going to be congruent to itself? Ooh, y'all are going to have no time to do your homework. Yep, exactly. Reflexive. The most common answer that you will put on this entire next test is reflexive property. It's used all the time. The reflexive property is going to be used constantly because anytime two triangles share the same piece, it is going to be used to say that that piece can be congruent to itself. So anytime you have a picture where you use one side for this triangle on the left and the same side for the triangle on the right, you're going to say that it's congruent to itself by reflexive property. This is all going to lead us to things like ASA, or side, 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 or angle, angle, side. Any one of our 4 shortcuts can be used to be able to get to proving triangles congruent. So you're going to see when you get triangles, when you see a proof, it's going to look like this when you open it up. So first it's going to give you a picture, it's going to give you given information, and it's going to tell you what they want them to prove. So this is the way it starts, guys. Number one, put the given information. Angle 2 is congruent to angle 5. The reason that you know that is that it is given to you. It's that straightforward. All you're going to do is say move to the proof. On the electronic ones, you say move to proof. You're taking that given information, you're moving it to the proof. Okay? Now, you're not going to be able to write on the pictures on the screen. I highly, highly suggest you sketch the picture out real quick before you try these problems. You're going to mark angle 2 is congruent to angle 5. That's going to decide the final answer, so you need to mark on your picture. You're going to decide ASAs, SAS, whatever you're going to use. The next thing you're going to use is the second piece of given information, that angle 1 is congruent to angle 3. Again, number 2, the reason for that is just given. When it's given to you, it goes ahead and puts given in there most of the time when you're dropping them in. It is just going to be given. That's the only reason that they gave it to you. And we go up to our picture and we mark angle 1 congruent to angle 3. Put 2 marks on it, guys, because you already have 1 mark on these. Not all 4 of them are the same. These 2 are the same and these 2 are the same. So put 1 mark on 2 and 5. Put 2 marks on 1 and 3. Now in this triangle, in these triangles, they share a common side. They share this segment right here. And what do we know when they share one? It's going to be congruent to what? What did we just say? What property just said? If it's shared by both of them, what do we know? Yep, it's reflexive. That's the reason, is that it's reflexive property. That's the reason that's congruent, but what is it congruent to? It's congruent to itself. So we're going to write for number 3 that FH is congruent to FH. And guys, when you do a segment, it's got to have the bar over it. I'm going to tell you right now, if you don't put the bar over it, it's not going to mark it right. It's a segment. You have to put that bar over it. There's a tool that lets you put the bar over it on the assignment today. In ALEKS, you can put the bar over it. This is why we're doing so much in ALEKS, because in years past, like when we didn't do them in ALEKS, when they got to take the EOC, they didn't know how to write things in here, and they would miss things like not putting the bar over it. They wouldn't know that until they got their scores back. We finally figured out that's the kind of things they were doing, and we started using ALEKS more, and our scores went up drastically. Now that we have that, we're going to mark that congruent to itself. Now, what order do these go in on this picture? What? Angle, angle, side. Does the bottom do the same thing? Yes, angle, angle, side. Once you have a shortcut that works out of those 4 shortcuts, you can say the prove statement. You're just going to put and take the prove. You say move to the proof. It'll let you move it to the proof. And you're literally just going to take this and do triangle FGH. You don't even have to write it. You just got to go through and write out, copy it. What's there, you're not having to create it. Is going to be congruent to triangle FEH. That means the triangle that's on the top is congruent to the triangle on the bottom. And the reason would be one of our 4 shortcuts. Well, we already wrote down which shortcut it was. We did it up here. You've already done the work. It's angle, angle, side. That's it. You're done. You've proven the triangle's congruent. Question? Yep. No, it can have more, and I'll show you that in the next one. This was a very direct proof. There may be one where it says things like the angles are right angles, and then the next thing you have to say is because they're right angles, they're congruent to each other. So it adds one more step to it. I'll show you, though. I'm not going to give you one that's. I'll give you at least an example that's as hard as the hardest one. Okay? Anybody else? There's also stuff about bisecting. You'll see. Anybody else? Now, I will tell you that most of them are pretty direct on the assignment today. I'm kind of gave you some, and then some build up a little bit. But we're building a little bit at a time. Okay, here we go. The next one. Again, guys, start with the given information. Number one is that HF bisects EG. That means, bisects means it cuts it in half. So that's given to you. Take a minute, write that down. But once you get that written down, what does that actually mean? This line right here cuts the line at the bottom in half so that this side is going to be congruent to this side. Bisect just means they're equal parts. And the one at the end is the one that's going to be the one that's bisected. So the EG is the one that's cut in half. So this segment now has these marks on it. Okay. Now, because it has those marks on it, what do we know about those two pieces? They're what to each other? Congruent. Perfect. So it's going to be EF is now going to be congruent to GF. I don't care what order you put the letters, as long as you get the connection between the two. Just, there's no correspondence that you need to worry about. Just make sure you get those letters together. And what would the reason be? What did we do up here? Bisected a what? What is this thing with the ball on the top? Not a line. Lines have arrows. A segment. So we bisected a segment. So the reason is a segment bisector. Guys, it's like truly, just look at the one above it, whatever that is, that's telling you what the reason is on the next one. Yes. Because I'm about to use it now. I first wanted to get what information it gave me first. Can you do it in that order? Yes. But then you got to pull the given, what it tells you from the given information each time. So the others were just direct. It just told you the things were congruent. This time, what did HF bisecting EG tell me? It told me that EF was congruent to GF, and I wanted to get that down first. Okay. Is that good? Okay. So now I'm going to use the other piece of given information. You could do it second, you could do it third, it doesn't matter, as long as you got it there. Okay? Angle 2 and angle 3 are right angles. All I'm doing is copying it. My reason for that is just given. All I did was literally just take it from the stack and drop it down in there. Once you drop that in there, draw the right angles on the picture. And guys, if they're right angles, what do we know about them? They're congruent. So number 4 is going to be that they're congruent to each other. Angle 2 is congruent to angle 3 because what? Look at your list. We wrote it in the very beginning. Not reflexive. That says something's congruent to itself. What says something about the right angles being congruent? Yep. All right angles are congruent. And again, guys, you're picking from a list for these. It's not like you're coming up with these out of your head every time. You don't have to memorize as far as like what they are written out as. What you do have to know is what they mean. So, guys, if the right angles are congruent to each other, you say all right angles are congruent. Okay, we have one last thing, guys. What else do we know in that picture? Just from looking at the picture, what do we know? Something is congruent to itself. What's congruent to itself? Nope, there's nothing that tells me those two angles are congruent. What is shared by both triangles? FH. FH is going to be congruent to itself. Nicely done. 5 says that FH is going to be congruent to FH. Okay, guys, I think I've said it enough. What says something is congruent to itself? Yeah, reflexive property. Reflexive property is going to say something is congruent to itself. Now, guys, look at your picture. You have a side, an angle, and a side. This is SAS. On the other one, you've got a side connected to an angle, connected to a side. So this one goes SAS. We can now prove the triangle's congruent. So all we do is take the prove and drop it down here as our last item. It's going to be triangle EFH is congruent to triangle GFH. And what's the reason going to be? Guys, what's the reason? We already wrote it down. SAS. It's the SAS. We wrote it. Whatever you write for the reason the triangles are congruent here, that's the reason the triangles are congruent right here. So, do you see it's going to have more than four sometimes? It just depends on what it gives you. Basically, if this piece of information is just giving you a piece of information, not like just a direct, these are congruent, you're going to need an extra piece of information. Okay, let me say that one more time. Unless these say that just two things are congruent, you need an extra piece of information from that information they're giving you. We'll show you what you mean on the next one. The next one, it gives us two pieces of information. Okay, anybody on this one? And again, you're dropping it in, you're not really doing the writing of it, so it's a little bit more direct, a little bit more straightforward on the other one. I think this is our last one, right? Yeah? Okay. Because I want y'all to try some while you're here. Okay, guys, here we go. First one, there's only one piece of given information here, but it gives us two things out of it. You'll see in a second. BD and AE bisect each other. So bisect means cut into two equal parts, and they're cutting each other into two equal parts. That means both lines are being cut in half. So BD is being cut in half, so that this piece is going to be congruent to this piece. That's the first thing. And AE is being cut in half, so that this piece is going to be congruent to this piece. Now, we just marked the picture. Now we need to write that. So number one, our reason is given. Get that on there first. Number two is going to be to say that those pieces are congruent. We just marked them congruent. Now we need to say it. So number two is going to be that BP, that's not a B, BP is going to be congruent to DP. Number three is going to be the same thing. We'll put reasons in a second because the reason's the same thing for both of them. The other two that are going to be congruent are what and what? What else did we mark congruent, guys? AP and what? AP and EP, PE, doesn't matter. Now, the reasons for both of these are the same. What happened up here? What did this say? They bisect each other. So what's the reason going to be? Segment bisector. We're bisecting segments. So the reason is a segment bisector. If I could spell. Segment. My brain might stop working on that word. Bisector. And it's the same for both of them because we know both of these things. Both of these things come directly from this. Because of that, they're both a segment bisector. That's the reason for both of them. Now you have to be able to look at this picture and tell me one more thing. What else do you know just looking at this picture? They're vertical angles. We've got a vertical angle here and here. So we can say on number 4 that angle 1 is congruent to angle 2 because they are vertical angles are congruent. I don't remember what it says on there. They can say vertical angles are congruent. Definition of vertical angles, they're congruent because they're vertical. You can word it a lot of different ways, but vertical angles are congruent. Okay. Do you have enough to prove the triangle is congruent? How? By what? What has this got, guys? Look at it. A highlight. Let's make my highlighter smaller to work. This is a what, followed by a what, followed by a what? Side angle side. This goes SAS. This one also goes side, angle, and side. So this one goes SAS. So our reason, we already know the reason is SAS, guys. You can put that down automatically. What do I put on the other side? just put the proof. Yeah, just put the proof, guys. Whatever the proof is goes next to that. Number 5, you're just going to drop down the proof. It'll say move to the proof. You'll move this to the proof. Triangle ABP is congruent to triangle EDP, and the reason is that SAS. Okay, guys, now I need to talk to you about this once you get this open, because I want you to see how they move to the proof and how that works. So please go ahead and take your folders and put those up once you put your notes in there. And then go ahead and get your computers out and get logged into Alex, because it looks a little bit different on Alex. So I want you to see it.